Lesson 6 is on converting measures, and converting measures means that if you have a length or a mass or something that has been measured and you want to put it into different units, you would have to convert. So if someone tells you that they are 5 foot 6 inches and you want to know how many total inches that is, you would have to convert the feet into inches. Or if someone said that they were 120 pounds and you wanted to know how many kilograms that was, you'd have to convert it. So the two different sets of units that we use in the United States are customary, or sometimes I'll call them British units. And those are inches, feet, yards, miles, ounces, pints, quarts, gallons, pounds. And there's obviously more than that, but what we'll be using today: millimeters, centimeters, meters, kilometers. Those all go with metric system, and then milliliters, liters, grams, and kilograms. So metric and customary are two different sets. Metric is the easier of the two to convert within itself because it's based off of tens. As you can see in the equivalent measures table here, you have 1,000 equals 1, 100 equals 1, whereas on the length side for customary, you have 12 inches is a foot, 3 feet is a yard, 5,280 feet is a mile, some kind of random numbers. Everything on the metric side is based off of tens. So converting from one unit to another involves multiplication or division by a constant that defines the relationship between units. So the number of the first unit times that constant equals the number of the second unit. And what we're going to find as we go through these is that every single time you have something that is equal, you can base two fractions off of it. So if I have 12 inches equals 1 foot, then the constant could either be 12 inches per 1 foot, or it could be 1 foot per 12 inches. And every single one, you can have the left unit on top of the right, or the right unit on top of the left. And it depends on which unit you're going from and going to, that you will, which fraction you're going to use. So we're going to use what we learned in lesson 5, which was multiplying by fractions. Remember, the top number is multiplied, the bottom number is divided. And we're going to use that to convert. On the left-hand side, it says the symbol squiggly line equal means approximately equal to. So if you do straight lines, it's equal, or if there's any rounding, you need to do squiggly lines. So the first example says, Reggie took 36 big steps to walk the length of the hallway. If each big step was about a yard, then the hallway was about how many feet long? So on the previous table, we saw that 3 feet equals 1 yard. So we could come up with two fractions. We could have the 3 feet on top per 1 yard on the bottom, or, whoops, I don't want to say equals, or we can have the 1 yard on top and the 3 feet on the bottom. And now we're going to look at our situation and decide which of those two is going to work for this situation. So he took 36 big steps, and it says each step is about a yard. So we could also say that that was 36 yards. So we have 36 yards. Now when I start off, I typically put it over 1, because something over 1 means it's getting divided by 1 and it stays the same. But now it's in fraction form and I can kind of see it a little bit easier. So right now, yards is in the top. To cancel out yards, I need it to be in the bottom of the next fraction, because I want to get rid of yards and end up with a new unit. And when things are diagonal and fractions, they get canceled out because yards divided by yards equals 1, basically. So the fraction that has yards in the bottom that we made up here based on our equivalent measures is 3 feet on top, 1 yard on the bottom. So yards cancel out, and I'm left with the unit that has not been canceled out, feet. And I want to know how many feet long is it, so that's a good thing. So now I go through. Numerator of a fraction gets multiplied, so 36 yards times 3 feet, 36 times 3, well I got 36, and then 72, and then 108. And then I divide by 1, but that's going to keep it the same. So I have 108 feet. Now it's a little bit differently than they showed you up here. I think it's a little bit more intuitive once you know that you need to get the units diagonal from each other so that they cancel out. This way you're always kind of guessing, am I multiplying or dividing? So example 2, a full 2-liter beverage bottle contains how many milliliters of liquid? So we have a 2-liter bottle, and the conversion from the table says that 1,000 milliliter, liter gets capitalized, milli means 1,000, so it makes sense that there would be 1,000 in 1 liter, equals 1 liter. So from this we can make 2 different fractions. We can have 1,000 milliliters on top of 1 liter, or we can have 1 liter on top of 1,000 milliliters. So now we're going to look at our situation and decide which of these is helpful. So we have 2 liters, and we want to know how many milliliters there are. So again, I'm going to write 2 liters. I'm going to put it over 1 so I can see that it's on top. And then I'm going to know if I have liters here, to cancel those out and get new units, liters needs to be on the bottom in the next fraction. So I find the one of my fractions where liters is in the bottom. And so I have 1,000 milliliters per 1 liter. Since liters are diagonal, they're going to cancel out. And then I can go through and multiply. 2 times 1,000, since 1,000 is in the numerator, is 2,000. And then I would divide by 1, but that's going to keep it the same. So I have 2,000. And then milliliters have not been canceled out, so those units are still there. So my units are milliliters, which is what I wanted to get. Example 3. The 5,000 meter run is an Olympic event. How many kilometers is 5,000 meters? So we have from our conversion table that 1,000 meters equals 1 kilometer. Kilo means 1,000. So I can come up with the 2 fractions of 1,000 meters per 1 kilometer, or 1 kilometer per 1,000 meters. And then I'm going to look at my problem, and I see that I have 5,000 meters. And again, I put it over 1 because it looks like a fraction. It doesn't change the number 5,000 at all. And I see that meters is on top, which means that in the next fraction, it needs to go on the bottom to cancel out. So I go and I look. Well, the one that has meters on the bottom is this one. So I have 1,000 meters per 1 kilometer. And so now I would do 5,000 times 1, the numerator, which is 5,000, and then divided by 1,000. So 5,000 times the numerator 1 divided by the denominator 1,000 is equal to 5. And since kilometers have not been crossed out, those are my units. The way that the book does it is they do a multiplication division problem, and they write it out that the number of kilometers times the number of meters per kilometer equals 5,000, and then they know, well, to get this one, I'm going to have to divide by this 1,000 here. It's not as intuitive to me to do it that way. If this way makes sense to you, then feel free to do it. I like the visual fraction way because as soon as I write a meters on top, I know that it has to go in the bottom of the next one so that it cancels out. And that way I'm always guaranteed to be multiplying and dividing correctly. Example 4 says James weighed 8 pounds 10 ounces at birth. How many ounces did James weigh? So if we look at our table, we know that 1 pound is equal to 16 ounces. So we can have the fraction 1 pound per 16 ounces, or we can have the, I should probably make those look more like 1 since they're next to LB. So, or we can have 16 ounces per 1 pound. So now we're going to look, and I need to convert 8 pounds. So I'm going to do that up to the right here. So we have 8 pounds, and I put it over 1. Doesn't change it at all, but it reminds me that pounds are in the top. So then pounds need to go in the bottom of the next fraction so that they're diagonal from the pounds I have and they can cancel out. So the one that has pounds in the bottom is this one. So I have 16 ounces per 1 pound. So then 8 times 16, since it's on the top, well, 8 times 10 is 80. 8 times 6 is 48, so that would give me 128 ounces. And since ounces have not been canceled out, those are my units. But he also was 10 ounces on top of the 8 pounds. So now we have to take that 128 ounces and add on the extra 10 ounces. So he was 138 ounces at birth. So the 128 ounces is the 8 pounds, and then 10 ounces. All right, practice set. A room is 15 feet long and 12 feet wide. What are the length and width of the room in yards? So if we look at our conversion table, we know that 3 feet equals 1 yard. So I can get the fraction 3 feet per 1 yard, or 1 yard per 3 feet. So now I'm going to convert 15 feet and 12 feet. So I have 15 feet on top. Since feet is on top, I know that it needs to go on the bottom of the next one. So the one that has feet on the bottom is this. So 1 yard and 3 feet. Feet cancel out. And I have 15 times 1 divided by 3. 15 times 1 is still 15. Divided by 3 is 5. And yards is my unit. since it has not been canceled out. And then I'm going to do that again with the 12 feet. So I have 12 feet, put it over 1 to make sure it's a fraction. Feet's on top in the first one, so it's got to be on the bottom in the next one to cancel out. And that's still the same one we used. So I have 1 yard and 3 feet. Feet are diagonal from each other, so they cancel out. So I have 12 times 1 divided by 3. 12 times 1 is 12, divided by 3 is 4. So the length is 5 yards, and the width is 4 yards. All right, B. Nathan is 6 feet 2 inches tall. How many inches tall is Nathan? So, for feet, if we look at the conversion, we have 12 inches equals 1 foot. And the two fractions that we can get are 12 inches per 1 foot, or 1 foot per 12 inches. And so we're going to have Nathan be 6 feet. Put it over 1. I have feet on top, which means that feet needs to go on the bottom of the next fraction. So I look back at my two fractions I made. The one that has feet on the bottom looks like this. So I put 12 inches on top and 1 foot on the bottom. So then I have 6 times 12 is 72. 6 times 10 is 60, plus 6 times 2 is 12 is 72. So feet cancel out since they're diagonal. I'm left with inches. So I have 72 inches. And then he's also 2 inches tall on top of that 72 inches. So I have to add on 2 inches. So that gives me 74 inches total. I know that's reasonable. I'm 5'10", and I know I'm 70 inches. So 6 feet 2 is 4 inches taller than me, so 74. And then in C, it says how many meters, 7 kilometers is how many meters. So to start with, we write our conversion that 1,000 meters equals 1 kilometer. And then we can have the fraction 1,000 meters per 1 kilometer, or 1 kilometer per 1,000 meters. Then I'm going to do 7 kilometers over 1. Since I have kilometers on top here, it needs to be on the bottom here. That means I'm choosing this fraction. Kilometers are diagonal, so they'll cancel. And then I have 7 times 1,000, which is 7,000, divided by 1, which is still 7,000. And my units are meters, since those have not been canceled out.